In this video, we will look at inverses as they pertain to parabolas, which is a bit less common than exponentials turning into log graphs, but the process is pretty similar. So for starters, we need to notice that fx equals ax squared and x is less than naught. So if we enter the realm of the inverse, then we need to change the restriction to y equals less than or equal to naught. So just remember that. If we enter into the realm of the inverse, then the point would switch and become minus 8 minus 6. So just keep that in the back of your mind. How do I find a? How do I find any missing letter in any graph? I just sub in a point and they've given me 1. So the y value is minus 8. The x value is minus 6. Careful to keep it in brackets. That's just 36, positive 36. And if I divide both sides by positive 36, I end up getting minus 2 over 9. I like to, as a habit, so that is the answer. You've done question A, you find the value of A. I like to just rewrite the original equation just for myself. And so a is minus 2 over 9 x squared. So there's the graph. Because now when they ask me for the inverse, step 1, I just swap x and y. And you're probably getting used to that if you're getting slightly deeper into this section. Then your goal is to try and get y by itself. And so for starters, I'm just going to divide x by minus 2 over 9, and that becomes 9 over minus 2. And if I need y by itself, I'm going to square root both sides. And I've noticed, because I was fastidious in the beginning, I've noticed that the restriction of the inverse is that y must be less than naught. So when I square root and I get plus minus, I'm only going to choose the one where y is less than 0, the negative. And so it's negative square root negative 9x equals y. So there's our inverse. You might be thinking, isn't this an issue because I got a negative in the square root? And you are correct. You should never have negatives in the square root. And so in one of our other videos, when you have these inverse parabolas, which are surd equations, you always need to generate your own restriction. We've got one of the restrictions of the inverse because we looked out for it right in the beginning. But the other restriction would be that this cannot be negative in here. And so it's fine. All it means is that x must just be less than or equal to 0. Because if x was a negative, then a negative and a negative would be a positive and we'd be back at the party. So these are our two restrictions. Write down the range of the inverse. Again, in one of the other videos, that is the quick way to do it, is just to work out the domain of the original. And so the domain of the original, the x values of this original graph are just x is less than or equal to naught. And so the range would then simply be y is less than or equal to naught. If this is from the original, then to get an inverse I, just swap the x and y. So that's the quick party tricks way of doing it. But otherwise, visually, what would your inverse graph look like? It's 0, 0, and if you switch that, it's still 0, 0. And if you needed another point to know which way is it going, like we did earlier, you just swap the x and y value. So it's minus 8 back and minus 6 down. So it would be somewhere like here. And so it would look something a bit like that. So there would be another point. You would be drawing a little bit more accurately than I would. Then the last question, f is reflected about the line y equals x. That is just the line that creates the inverse. Okay, so we've already done that here. Here is the inverse equation, so you don't need to redo anything. And then it's reflected about the line, the x-axis. When I reflect about the x-axis, the y becomes negative. So I'm going to rewrite the inverse equation, except when I reflect about the x-axis, the y just becomes negative. And so what I could do is divide both sides by a negative, and I'll end up just with something like that. But to be cautious, I would just include x must be less than or equal to 0, just to not end up with a negative inside the square root. So I hope that you find it helpful to look at a parabola as it pertains to inverses, just something a little bit different. If you did, please like this video, subscribe to our channel, and share it with your friends.